So the next topic is referred to data scales. So in ArcGIS in general, and probably in all your life, you will work with two groups of data. The first group is qualitative and the second group is quantitative data. And each of these groups are divided into two types of data scales. The qualitative data scale is divided into nominal and ordinal, while quantitative has the interval and ratio data scales. So nominal scale. A nominal scale is a scale of measurement used to assign events or objects into discrete categories. This form of scale does not require the use of numeric values or categories ranked by class, but simply unique identifiers to label each distinct category. So you can see on the examples below, the first map on the left side is a land cover and land use and land cover class. So this is a discrete raster data, and each land cover and land use has its value within the attribute table and just raster value, right? The same concerns soil map of the Netherlands, which are divided into soil types: peat, sandy peat, loam, clay, etc. So this is also discrete type of raster data, and each raster class has its own raster value. And the last example is the map of vector map of Canada and United States, and which show the ethnic distribution, the ethnic distribution of each state of Canada and United States, which is also discrete data, and these are all referred to a nominal data scale when you just distinguish your data according to some discrepancies, some differences. But these differences do not have the advantage or disadvantage, or do not have the order. You cannot compare that. You cannot say that this class is better than other class, etc. So this is the most simple type of classification of your data. The second one is ordinal scale. Ordinal indicates order. Ordinal data is quantity. No, not quantity. Sorry, here is a mistake. Here's qualitative data also, because qualitative data, because ordinal and interval refers to both qualitative type of information which have natural occurring orders, and the difference between is unknown. It can be named, grouped, and also ranked. So we can see here the maps of the two maps. The first map is groundwater potential zones of the certain area, right? And see, you can see the classes of this map: very poor, poor, good, very good, etc. What is the difference between this type of data scale from the nominal scale? You can order these values, data scales, from low to high. For instance, very poor, poor, and good are different. We can say that good groundwater potential zones is better than poor, and poor is better than very poor. So you can make an order between classes. The same concerns the map on the right side, which shows the salinity of the area. So moderately saline, non-saline, and slightly saline. So you can say that you can also make an order between these classes: which one is better, which one is worse, etc. So this is the difference between the ordinal scale and nominal scale. If you in nominal scale you cannot compare the classes, in ordinal scale you can compare the classes. So these are both qualitative type of information, not quantitative. You can see here there is no quantitative data here: poor, very poor, etc. So a qualitative type of information mostly described with the text, while quantitative with numbers, either integer or float. Interval scale. The interval scale is a quantitative measurement scale where there is order. The difference between the two variables is meaningful and equal, and the presence of zero is arbitrary. So one type of interval scale is temperature or precipitation values. So they are both described with the numbers, right? See here, mostly integer values. Um, and also it has a meaningful the presence of zero, and zero number here is represent the also can change the difference between two variables are here are meaningful, and each all your data scale is divided into classes with certain interval, and each class is represented with the quantitative measurements. Then the last one is ratio scale. A ratio scale is a quantitative scale where there is a true zero and equal intervals between neighboring points. Unlike on an interval scale, a zero on a ratio scale means there is a total absence of the variable you're measuring. For instance, two examples here: countries by GDP per capita and population density, right? So they both can have 0 point, right? Zero value. It means that there is no population, or 0% of value of GDP in dollars. There is no production at all. And you can also make order between each classes, right? Here there is orders from low to high, and here also the same here. And also they all have, as an interval scale, they have the intervals. But the difference between ratio and interval, it has a true zero, which means that there is no information at all. For instance, interval scale can have also minus values, while the ratio scale cannot have the minus value. The minimum of the ratio scale is always 0. So this figure represents the level of difference between comparing level of difference of each data scale. The more simple type of data scale is nominal scale. It can divide your data only into categories, but it cannot make the order between each class, comparing to ordinal scale, which besides the categories has a rank order. And the next more comprehensive data scale is interval scale. It can also divide your data into categories, makes the order between them, but also shows equal spacing, because it is a quantitative type of information, while nominal and ordinal cannot have the equal spacing because they are both qualitative type of information. And the last one is ratio scale, more complicated, the most complicated. It also can make divide your data into classes, make an order between them, and equal spacing, because it's also quantitative, but it also have the true zero compared to interval. So, and the next topic is the 12 steps to present a map. You should remember these 12 steps to present a map in order to make a more effective map, and in order to order your tasks while doing a map. So the first step is, what is the purpose does the map serve? For instance, for what purposes you're doing this map? For instance, you're doing it for instance, for ecological purposes, scientific purposes, economic purposes, just educational purpose, etc. You should define for yourself. The second step is you should define what is the user group is aimed at. So for instance, for whom you're doing this map: for the farmers, for the students, for ordinary citizens, and for the general population. Is your user group is broad or it's small, etc. What is, and the next one, you should give the title of the map. You should name the name of the map. You should give the name to your map. This fourth step is what spatial components are to be displayed in the legend. So what type of spatial components you want to show on your legend. You should define what is the hierarchy between the components. For instance, if you're going to represent several layers, right? several maps on the on your just final map. For instance, you're showing the map of the groundwater potential zones, and you're adding roads, trails, and the locations of springs, etc. So we should define the hierarchy between the components. Also we should know what is the data scale of these components, and according to the data scale you can choose the appropriate map type in a symbology. Is it a single symbol, or you can define it by categories or quantities, etc. How many classes does each component contain? Which graphic symbols can be used? Which graphic attributes have to be included? And the last steps is add the north arrow and add the scale bar or reference grid. You can add both of them, and also you can add data source, text, and graphics. For instance, a data source can be the source you used, or also the text. You can write the name of the author of your map, etc. So a graphic symbol. Spatial data represented in a map always refers to real-world phenomena. This can be heights measured at specific points, traffic intensities measured along a road network, or numbers of inhabitants living in an area. We distinguish point, line, and area, features that refer to point, line, and area locations. Graphic attributes. All the differences imaginable between symbols can be summarized as being cases of 6 graphical variable size. These are gray value, grain or texture, color, hue, orientation, and shape. So this is the table where you can see all the differences in. For instance, you're showing either point, line, or polygons, and you can make the differences in size, right? So according to the data value of each point, the size can differ. For instance, you have the point vector dataset, which shows the water volume of the wells, and which is one attribute shows the water volume of each well, and the well which has the higher big water volume within it will have the larger size. So value also differs. You can see here, you can show the values, and also the grain, the color, one type of making this differentiation between your objects. Orientation, you can also make different orientations of your maps, but most of this refers to point data. And also shape. So these all differences the ArcGIS has within it, and you can just manipulate with all these differences to make your map more presentable, more understanding, and more attractive. The last topic is legend. So a legend tells a map reader the meaning of the symbols used to represent features on the map. Legends consist of examples of the symbols on the map with labels containing explanatory text. For instance, on the left side you can see the map of a certain area which has mountains, lakes, the city, junction city, roads, etc. And on the right side we can see what each symbol represents here. So these symbols on the top, right, represents interstate highway. These are state highway, and these blue colors are local roads. And here we can see that the population over 200,000, this points, right, while these are population from 500 to 600, 100. And you can see also the difference inside here between black, right? So they all have the population higher than 200,000, but this junction cities has a population much higher than 200,000. Or again, this I'm sorry, this was a mistake. Population under 100,000. These areas, right? These towns. And camp this triangle represents camping picnic areas, and this one is the international airport. So this is a legend of our map, and reading the legend, the other person can understand what your map is going to represent, what is the user group of your map, what is the purpose of your map. So map legends can be simple and complicated. And a legend wizard within ArcGIS helps us to make a map legend. At first, choose which map layers you want to be part of the legend, set the number of columns in the legend, and create and symbolize a legend title. Create and symbolize a border and background of the legend. Customize the shape and size of the legend patches, and set the spacing between legend elements. So here we can see the number of map layers, right, you're working with: capital, cities, rivers, lakes, states, etc. And you just going to represent only these three layers, right? Capital, cities, highways, states, etc. And you put the set number of columns in your legend into one, because when you, for instance, take two columns, your legend will also have two columns. For instance, you took 3 columns, and your general legend will represent it within 3 columns. You have the option to remove any layers of the layers list. For instance, by clicking this button, you can remove one or other layers from your legend items. You can reorder the layers list as you see fit with these buttons, right? You can reorder your data. This panel of the wizard also provides options to set the number of columns in the legend. And when you click the next, you see the legend title. You can change the legend title. Also, you can change the color, size, and font of the text which the legend title should be represented with. And next one is the legend frame, right? You can change the difference between border, background, and drop shadow of your legend border. And the next one is you can change the size and shape of the symbol patch used to represent line and polygon features in your legend. And the last one is set the appropriate spacing between the parts of your legend. So these are the last two parts are not very necessary. You can just change the border of your legend frame and give the name to your legend, and choose the layers you want to represent. So this is the end of this lecture, and let's start our tutorials in order to understand better the map representation.